In section 3.1, we looked at if you were given the zeros of your quadratic function and an extra point somewhere on the curve, how do you find the equation of that parabola? So we're going to do something similar in this section, but we're going to do that if you're given the vertex and an extra point somewhere else on the curve. How do you use that information to get the equation? Okay, so we'll use that vertex form. Y is equal to a times x minus h squared plus k. And these steps are going to be really similar to the steps that we used for the zeros of the point. The only difference is the first step. So that very first step is you're going to take the coordinates of your vertex and plug your h and your k into this vertex form. After that, these instructions are going to be the same as they were before. So you're going to use that extra point you have, and you'll plug that in for the x and the y here. And then you'll simplify that and solve for a. And then you're just going to plug a into what you did in step 1, and that's going to be your formula. So let's give this a try with number 4. So I need to find the vertex, which is right here. It's going to be a min. And this is -3, 2 is my vertex. And then I need an extra point somewhere on here. And this one looks like it's going to be nice and easy to figure out because it sits right on the corner of a box. So I know the x here is 0, and the y is 5. So I have my vertex and my point. And step 1, I'm going to fill this in. So I have y is equal to a times x minus h. So x minus a minus 3 will be plus 3 squared, and then plus k, so plus 2. So there's my h and k plugged in. And then next I'm going to plug in this point here. So I get 5 is equal to a times 0 plus 3 squared plus 2. And then I'm going to simplify this. So I will subtract the 2 over here. That gives me 3 is equal to a. And then 0 plus 3 is 3, and 3 squared is 9. So I have 3 is equal to 9a. And I'll divide the 9 over to the other side. And that's going to give me that a is equal to 3/9 or 1/3. Right, and the last step is just to plug this back into what we did in step 1. So my equation here is y is equal to 1/3 x plus 3 quantity squared plus 2. All right, I would like you to go ahead and pause the video, give this a try. You've got 3 other problems here, 1 with the graph and 2 written in words. Give this a try, see how you're doing with this idea, because this will be a problem on the test to do this, and it is at least a 10-point problem, so I want you to feel really confident with this. All right, so let's give this a try. I'll do this other graph one here. So my vertex here is a max instead of a min, because my function is concave down. And those coordinates are 2, 3. And then I need another point, trying to find one that's right on the corner of the square. So this looks like it's a nice solid point to use here. That is 0, and -1 is the y value. And then I'm ready to plug my vertex in. So I have y is equal to a times x minus h, so x minus 2 squared, plus k, so plus 3. And then I'm going to plug in my point for x and y. So I have -1 is equal to a times 0 minus 2 squared plus 3. And I'm going to subtract the 3 back over to this side. So I have -4 is equal to a. And then this is -2 squared. So that'll be 4. So a is -4 over 4, which is -1. And then all I need to do is put this back into what I did in step 1. So y is equal to -1, x minus 2 squared plus 3. All right, number 6, they gave us the information without the graph, so I don't have to count boxes, which is kind of nice. So step 1, y is equal to a, x minus h, so x minus 2 squared plus k, so it'd be plus of minus 3. So I'm just going to put minus 3 here. And then here's the point I'm going to plug in. So my y value is a 3 is equal to a, and x is 4, so 4 minus 2 squared minus 3. All right, so I'm going to add this 3 over to the other side, so that gives me 6 is equal to a. And 4 minus 2 is 2, and then 2 squared is 4. So I get that a is equal to 6 over 4, or 3 over 2. And I'm going to plug this back into step 1, and I'll have my equation. So y is equal to 3 halves x minus 2 squared minus 3. All right, and then one last one here. So this one requires you to figure out what this point is. So this is the y-intercept. And the y-intercept happens when x is equal to 0. So this point here is 0, 6. All right, we'll plug in our vertex first. So y is equal to a, x minus h, my h is a 4, squared, plus k, so plus 2. Step 2, I'll plug in this point that I found a minute ago. So 6 is equal to a, 0 minus 4 squared, plus 2. And then I'm going to solve for a, so I'll subtract the 2 over here. That gives me 4 is equal to a. 0 minus 4 is negative 4. And then negative 4 squared is negative 4 times negative 4, so that'll give me a 16 here. So a is 4 over 16, which is 1/4. And then I just plug this back into step 1. So y is 1/4 x minus 4 squared plus 2. All right. So you have just another way of figuring out, finding that equation depending on what information you're given about your function.